I'm not going to lie to you. This is going to be a technical talk, but I don't know what I'm doing, so it's fine. It's a bluffer's guide. So I figure that the people who come to Meteor, some of you are like supreme wizards, and you know what you're doing, and you do it every day, and you're a professional. And some people are just getting started, and maybe they're just getting started with programming as well. So the intention behind this talk was to just pick an interesting technical feature of Meteor and just try and do the simplest explanation that I could muster of that feature. I failed completely because in trying to do that, I was like, well, I can't really explain this without that. So what I'm going to do is start at the start. This is a 45-minute timer. If I'm still talking in 45 minutes, you should just execute me somewhere early. I'm going to try and talk about cooperative multitasking, and obviously, like that is deliberately like a tricky term. So what I'm going to try and do is break down just like the simple steps of multitasking and processes and threads. So I'll stop introducing the talk and do the talk. A Bluffer's Guide to Cooperative Multitasking, Part 1. There's a clue there. Or the longer form title, Process, Thread, Fiber, Async, Callback, Event Loop, OMG, WTF, Barbecue! Some caveats apply. I have no idea what I'm doing. There's a room full of people staring at me. I'm running this event for months and months and months and years now. I used to have to give a lot of talks, and then for like the last 12 months I haven't given any tech talks, and I'd forgotten how incredibly scary it is. But you should all do one because it makes you a stronger person if assuming it doesn't kill you. I have no idea what I'm doing, but hey, it'll be fun. We'll learn a thing. So, cooperative multitasking. To get to a definition of cooperative multitasking, we're going to need to define some concepts. And these may be concepts that we all think we understand already. But as I discovered trying to write this talk I tried to make it a one-part talk, and I couldn't. So I discovered along the way that there's more to these concepts than meets the eye. Define multitasking. Okay, I'll do it. Simultaneous. Good, it's a good start. If you read Wikipedia at great length, it will say multiple processes are performed during the same period of time. Seems pretty obvious. They are executed concurrently. That's important. In overlapping time periods, new tasks started before others have ended, instead of sequentially. So we want the racehorses. We want two things happening at the same time. This is the essence of multitasking. Also of note, multitasking allows multiple processes to share CPUs and other system resources. Each CPU executes a single task at a time. Single task at a time. Interesting. So we want to do two things at once, but only one task can execute at once. Multitasking allows each processor to switch between processes that are being executed without having to wait for each task to finish. So at the process level, the operating system is allowed to swap in and out processes. Maybe this is just old hat to everyone, but it was a useful refresher. So our operating system is slicing and dicing a series of processes. So multitasking, in summation, doing several things at once. Time sharing the system resources, and most notably, it's defined in terms of processes. Define process. All right, I'll do it. There will be a test later. Define process. An instance of a computer program that is being executed. Now, for me, this is a terribly circular definition of anything, but this is what Wikipedia says, so it must be true. A program is a passive collection of instructions. A process is the actual execution of those instructions. So this process is a living thing. I've spent far too long with computers. The process is the runtime version of this static code. So the program, static definition, we write programs, we run processes. The operating system multitasks our processes by slicing and dicing time on the CPU. Everyone with me so far? Good. Some examples. So we all kind of intuitively know what processes are, but there's this duality to them where it is both the program, the concept, MongoDB, or Node. So, statically it is Node.js, you go and download it, or it's Hyojus, I think is the correct pronunciation, IOJS. Meteor is an interesting one, because we have a command line tool, a program called Meteor. But when we execute Meteor, what's happening behind the scenes is that there are multiple processes being spun up. So there's a Node process running your server, and there is a Mongo process running your database, and they are talking to each other. We can demo that. It's not the most exciting demo in the world, because hopefully some of you have seen this before, but there's a process doing a thing. So, I can ask my terminal, which node? And it will tell me that it's going to run the program that's stored in user local bin node. Or I can run node and get an interpreter. The interpreter is going to show me some stuff. That's not so exciting just now. I could run mongod. That would start running a Mongo server. So I've got mongod the program as a thing on my path, and I've got mongod the process, which is now running. What am I talking about? Nonsense.
I never thought of MongoJS
Mongod. MongoD. I always call it Mongod because that's what I see when I see it written down. What are you talking about? There's no hyphenation, there's no capitalization. It's Mongod. It's MongoD. You're right, D is a standard suffix, so in the old law world you have HTTPD or Apache D. Like a daemon process is typically suffixed with D. And correct, it's Mongo, it's D, MongoD. Mongod. Okay, cool. So, processes, programs. So like Node as a program is installed on my machine, Meteor as a program is installed on my machine, but what's more exciting is like running these things and having multiple of them running and not being scared of that. So I'm going to kill this guy by hitting Control and C. He's dead. He's dead. What am I going to do? So if I do something like PS and then I pipe that into grep, is this big enough? Let's put it in the middle. Yeah, now we can see both. So PS, P isn't a thing. PS gives me a list of processes, that's great. PS piped into grep, and I ask it to grep for node, will give me all the node processes running on my machine. I don't know if that's totally clear, but process lists all processes, grep piped into grep, so the output of process piped into this grepping program, which is a search tool, looking for the word node in the output and showing all lines that contain the word node. So I can see I got 3 of them, so that's kind of fun. But what I kind of like to do is pipe that into word count, which is another program, and give it the -L. So word count counts words. Unix people, they know how to name things. Word count counts words. They give it the -L flag, gets more confusing, counts lines, not words. It's radical. So I can see that I've got 3 node processes running. This is distracting. This is what I'm talking about. Okay. In the shell. Or a process in JavaScript, in a Node program, in a Meteor program that's using Node under the hood. I can inspect my parent, my lineage. Let's try that. So I can do something like just run Node. So if you give Node a file that's a JavaScript file, it'll run it. If you just run it without a file, it gives you this REPL, this feedback loop, this interactive Node world. So I can do really boring things like console, log. Oh, hi. Oh, deliberate mistake. Anyone know what this will do? That's right. Hi. So that's not very interesting. But there are some APIs in Node that let you inspect weird, like, so there's this notion of like I'm a running program, but I can inspect myself. So like process is an object, and let's say process.name. What is the name of this process? Undefined. What is the title of this process? It's Node. What else does the process know about? The architecture of the insides of my laptop? Cathedrals contained in its mind. x64. What else does it know? Versions? Right. So a running Node process has an awareness of the process that it is within. But if these versions are sort of, they speak for themselves. It tells you what version of V8 you're running, what version of Node you're running, la-di-da, not so exciting. Obviously, like, this one's getting more exciting as every week goes by. Ooh. Not relevant. Moving on. So, inside a Node program, we can introspect the process. So, has everyone remembered things defined so far? Multitasking, processes appearing to operate simultaneously, a process, an executing program. Good. If we can inspect the process, then what are we? Are we a can I inspect myself? I don't know. Also of note, multiple threads can exist within the same process and share resources. Now, what would that mean? It's a thought experiment. I hope that the ideas are popping up inside your heads. If, say, you've programmed in Java, this will be very natural to you. Java has an internal notion of threading and threads, and you can create many of them. So a process is data and the code for running a program, started and stopped at our whim by the operating system. You know, I don't get in there with a magnet. And processes share CPU time, but they don't share state. They can share file handles to the same file on the hard drive, but it's not the same as sharing like address space in memory. They are isolated from each other. I'm talking in generalities. People who are experts can correct me after the talk. Warning. Processes may contain threads. If you are allergic to threads, you should seek a process that is created in a thread-free environment. What's a thread? This is crazy talk. So my operating system is running many processes, but my process is running what now?
Process within process.
Oh my God. Exactly. It's all the way down. Define thread. A thread is, according to Wikipedia, the globally communally edited crazy house, the smallest sequence of programmed instructions that can be managed independently. So you see immediately the difficulty that a Wikipedia author has when trying to talk about threads in general for any possible programming language. So they've described it as the smallest sequence of programmed instructions that can be managed independently. Smallest sequence of okay, all right, that's a thread, is it? Cool. Multiple threads within a process share process state as well as memory and other resources. Oh, interesting. So multitasking is many processes running at once. A process is the executing code of my app. My process may contain multiple threads, and threads inside my process do share information. My processes don't in any kind of hardcore sense. They may talk to each other through Unix pipes and other things. But threads, everything gets a bit racier, pun intended. Because threads can share state between each other. They can literally like talk to the same memory addresses. That's what that says to me. I don't know if anyone else is reading the same words. Processes are typically independent while threads exist as a subset of the process. Perhaps a diagram will help. Now, I love this. If you go on Wikipedia and you search for threads, computer science, all the people in the world, some of whom are designers. I heard there was this thing called a unicorn, and not only is it a four-legged horse with a horn, but it's also this like weird guy who can program and a gender non-specific guy, person who can write squiggles, can write code and do drawings. But no, this is what Wikipedia says is a useful definition of. So what we can't see, because there's black text on the black background, sorry, this says the word process up here, and this circle represents a process. And I think these are that fancy spaghetti that you get that comes in spirals. And I think that all processes, there's an old folklore in Unix that says all of them must have 3 pieces of expensive spaghetti inside. Probably. I don't know. Maybe this one? Is that any clearer? Yes? No? This is that talk. Can't wait. Yeah, I don't know. Like, I think the sum total of human skill and talent could possibly come up with a diagrammatic version of processes and threads that was a bit clearer. But I think what this points to is that it's not something that, as humans, we have a particularly solid mental model about. Some people do, but they're not me, so I wrote this talk. What about JavaScript? So, you know, this is all very good. I've read Wikipedia and I've put it into slides, and that's cool. This is a Meteor meetup, like, well, hopefully we'll get to that. Let's start. JavaScript. Meteor uses JavaScript. Let's all agree on that. What does that look like? Oh, I Googled it, and, well, I mean, really, I should stop here. What you see here this guy, it's a typical server. Has anyone programmed in typical? No. Typical server, so I guess they're talking about maybe the original Apache HTTPD server, that you could fork processes or you could use threads. If you run Apache and you're trying to serve millions of people, suddenly that becomes really interesting to you, because if your Apache server forks processes, processes are more heavyweight than it internally spawning threads. I've never done this in production, so I'm talking out of my behind, but this is relevant to these people. We are these people. I don't. Yeah. Cool. I think what they're getting at is JavaScript has a single thread of execution. You can tell that because they haven't written the word thread on any of these. I mean, I think these look like threads, but they're not. Probably. JavaScript has a single thread of execution. Okay, so multitasking, processes running at the same time, apparently on a single CPU or maybe multiple CPUs. A process is my executing code, but it may also contain many threads of executing code. But in JavaScript, there's only one thread of executing code. I get it. Enhance. JavaScript has a single thread of execution visible to the scripts. Now, if anyone can Google up a better reference than Stack Overflow for the actual definition of JavaScript's threading model, and yes, I did look at the contents page of the ECMAScript standard. Thought that was the least I could do. I didn't find it. And I found lots of people on the internet saying they couldn't find it either. So better sources are welcome. If you can point me to a resource that clearly explains threading in JavaScript that isn't written by just some random person on the internet, but is in fact like a standard, that'd be great. I'm sure it exists. I ran out of time doing this talk because I got lost in a rabbit hole of reading Wikipedia. What did we say a thread was? The smallest sequence of instructions that can be managed independently. JavaScript has just the one. But it does have an event loop. What's an event loop? A programming construct that waits and dispatches events or messages in a program. Right. I've got a process with a thread in it. The thread is my code executing right now, but I've got an event loop as well. Yes. Great. The event loop is like any other loop. It just repeats the same process over and over again. Minutes before I started this talk, I found a much better resource that I would like to work into this talk at some other time. The MDN, the Mozilla Document Network, or whatever that acronym stands for, it has a really good page on this that kind of says, like, the event loop, there's no magic, it's just a loop. So a loop that says, are there any more tasks to do? When true, do the task. Loop, repeat. I was like, simple as that. Who knew? So the event loop works by making a request to some internal or external event provider. In the case of our code, if we're writing JavaScript, Node style, or in the browser, the event provider would be our thread, our file of code. Request an internal event, and then it calls the relevant event handler. This now starts to feel something familiar, like I'm back on solid ground. I do like on event function. This is a pattern that I'm familiar with. So the event loop, it's my friend. It's the thing that makes that work. Don't block the event loop, as a famous Winston Churchill quote. Okay, so what I really wanted to do was compare and contrast fibers and not fibers. That's going to be part 2, because what happened was, well, it got really late. I was up all night. All right, I'm going to get these. This is where the slides sort of break down a little bit. But you can see I did loads of preparation, so that's good. Okay, let's hide that. This is where slides come from. I don't know if you've ever seen that. That's where slides come from. Slides come from like Markdown and some coffee and evenings and lunch breaks, and you cram it into every spare minute of your time. So, right, people who block the event loop, bad things happen to them. They get unresponsive servers if they block the event loop in Node. They get janky UIs. They get that sort of, you can always see it, like if you just scroll and things just judder ever so slightly in your web front end. This is because people are giving the event loop too much to do. So, people who don't, that should read people who do. Let's fix it. Pull request welcome. Which do you want to be? So apparently JavaScript is simple if we ignore truthiness, type coercion, numbers, it is simple in the sense that, like me, it can only concentrate on one thing at a time. This single thread. When you call a function, the lines of code in that function are executed. That's that. No messing around. Now that might seem like the most boring sentence in the world. Seems like I'm not telling you anything new. I used to be a Java developer, and that is not true in Java. So, just going to say that. All right, it's getting long-winded. But here's the idea. If you are asked to do one small thing, and it's a good day, and you're not hungry, you'll probably get one small thing done. Probably. If you're asked to do a billion things, it'll probably take you a while. If you're super disciplined about it, and you don't take any breaks, it'll still take so long that your friends and family will start to get worried. You will become unresponsive. In this small way, code is the same. All right, here's some code. Here's a function. It's pretty rad. I don't know if anyone can read functions here, but this is one of them. Your JavaScript code may be made up, hopefully, of many of these. Hopefully, none of them do this. This function does things, and you can tell it how many things you'd like it to do. It's at least loosely aware that it's going to take a while to do these things. There's a clue because it's recording the current date when it starts running. Now, in a code review, that would definitely be a smell. That would be a flag. Why are you recording the time of that? Then there's this for loop. It's kind of regular. This bit, definitely weird, does nothing. Then records the date.now. It minuses the then from now, get a duration, super fun times. There's a clue down here of what's going to happen. Well, whoop, wait. But for funsies, so I don't know how many people, hands up here who's tried out the node REPL. 1, 2, 3, 4, 5. Okay, so it's worth just showing real quick. Like the node REPL is super handy. Similarly, like if you've ever just popped open the developer tools console in Firefox or in Chrome, and you just dropped in some JavaScript just to try it out, you don't have to like run your entire test suite if you don't want to. You can just drop some code in. If you're just experimenting with APIs, trying stuff out, so I can just paste in this function. Now it exists. Do things, and it's got autocomplete, which is great. I don't like do things 1. I did 1 things in 0 milliseconds. So 0 milliseconds is fast. It's fast enough for you. It's fast enough for me. 10 things in 0 milliseconds. Now, is this because my for loop is doing nothing? Does doing nothing take no time? That's the question. What about if we do 1e9 things? Now, I'd forgotten that JavaScript supports this other notation system, but this means 1 with 9 zeros after it. So that's like a billion things. Now, a billion things, it turns out, takes 2.5 seconds. But I'm not asking it to do anything. There's an amortized cost of recording the current date, right? Right? Like, recording the date, well, as we've discovered, if we do that 10 times, it takes 0 milliseconds. There's an amortized cost of then doing a subtraction. So this thing, if I do it a billion times, takes 2.5 seconds, but it's not doing anything. It's an outrage. But I'm not doing nothing. It's a very good point. I'm incrementing an arg. Something is happening. And a billion, it turns out, even everyone tells us that computers are getting faster and faster and faster. But it turns out a billion takes them some time. So check the condition, exactly. So there's 2 things I'm doing. I am incrementing a counter. What? I'm doing a Mark Stroud. Yeah, it's true. Do 10 things. Anyway, 2.5 seconds. It's crazy, right? I can do 10 things in no milliseconds, but I can do a billion things in 2.5 seconds. Rad. All right. Well, that's interesting. What do I do with this knowledge? So, as the procrastinators among us know all too well, sorry, this sounded a lot better when I was writing it at 2 in the morning. Even doing nothing can take ages if you do enough of it. True fact. If doing nothing can take ages, how the hell are we going to do 2 things at once? I don't know. JavaScript's got a single thread of execution. That's what everyone keeps telling me. Single thread of execution. Well, what if we wanted a server to handle 2 different users at the same time? I don't know. Sounds like it's not going to be possible. Typically speaking, servers have to handle many, many, many users. So this should be, I don't know, this should be easy. I am a server. And I do things that take a while. Zip it. So I'm just going to try and copy and paste this into my node REPL. So this is kind of loopy. No, I didn't really mean that pun. So I'm going to try and just paste a fully fledged server into error address in use. Superb. Let us say 1, 0, 0. I will stop talking soon, promise. Okay. Node and a server. Okay, I've got a server. I think it's running. No flipping way. What port is it running on? Okay. Apparently it's running on that port. So I've just copied and pasted some code into the node REPL, and I now should have a running server. Clear. So we can test that with the arcane magic that is curl. No one knows how curl works. but it seems to work. Curl, for anyone who's never used it, is a command line tool for making requests, making HTTP requests. Oh my God! So I'm running a server on port 1300. That server just responded for a very vanilla GET request with the fact that it did a billion things in 2.6 seconds. So we've now exposed our function to the internet. It's great. Super jazz. Now what's interesting here is that this time is what the server's telling us. The server's saying, I took 2.5 seconds. But being skeptical, I don't trust the server. So I'm going to wheel out time. Time lets us time a thing. It's pretty radical, I know. But if you've never used time, then this is news to you. Time go. OMG megalols. So the server says it took 2.7 seconds, and time also says it took 2.7 seconds. So okay, I agree. You're not lying to me. Now, how am I going to simulate multiple users? I could fire up multiple browsers like an animal and click buttons. I could pay for some kind of cloud-based load testing tool. Or I could invoke the wisdom of the ancients one more time. What is this thing? A, B. Now, there are lies, damn lies, and statistics. The same rules apply for load testing. But if you want to make multiple requests, there's this tool called AB. AB-H. No, that's that thing. AB is Apache Bench. It's a tool written a long time ago to load test the Apache web server. It still works. Let's try it. AB, I want to simulate one request just to prove that everything's working. If Apache Bench is behaving like I think it's behaving, then one request should take roughly 2.5 seconds. So I say, Apache Bench, give me one request to HTTP. What is it? HTTP. I think I got it in my yeah, this guy. Give me one request to this guy. Apache Bench. Benchmarking. Be patient. Okay, it's very demanding. Apache Bench says that at concurrency level 1, the time taken for request is 2.7 seconds. And the number that completed was 1, and 0 failed. And it did that many. And it took 2.7 seconds. Yeah, that all makes sense. That's a bit much. So what we might want to do is just try that again and use our grep friend again. And we would look for something like, I don't know, time, yeah. Grep time. Okay, that's a bit more useful. But it could be better.
2.707 seconds time per request. 2,706.997 ms mean. Time per request. 2,706.997 ms mean. Across all concurrent requests.
If you are going to launch a robot army of requests, the least you can do is have it sound like a robot. So, one request, 2.5 seconds. This has been driven home a little too hard, I feel. I can sort of sense the audience is starting to lose their thread, pun intended. I want to do 2 requests with a concurrency of 2. Now, in an ideal world, just because my server is slow doesn't mean my server doesn't multitask. I want it to be slow for you. I want it also to be slow for you, and I want it to be slow for this guy too. But I don't want it to be the sum of all the slownesses. If we all connect simultaneously, I'd like it to take 2.5 seconds for you, 2.5 seconds for you, 2.5 seconds for you. What I definitely don't want is it to serve your request very slowly, to serve your request very slowly once he's done with that request, and to serve your request even slower still, having completed the first 2 requests serially. This is not what anybody ever wants. Let's hope.
Time taken for tests, 5.450 seconds time per request.
Man, 5 seconds. Let's get rid of the say because it's, you know, it's getting in my way. I could use T. We could go there. That. This server is the worst possible server ever, and I hate it. Okay. What is the problem with this server? It's a node. It's a Hildress. Yeah. The real problem with this server, we just did loads of steps. The problem with this server is it is CPU bound. This for loop, despite doing nothing, takes time to execute. It is the currently executing thread in our node process. We know that our node process gives us an event loop. That's cool. The event loop is handling things like, well, create server has created a function that will be called back later when a request comes in. So this function gets executed many times, once per request. So the event loop is kind of handling, firing up this function every time a request comes in. But the event loop can only operate when the stack of executing things is empty. When the first request comes in, we start writing a response. We're like, yeah, everything's cool. It's a 200. It's going to be some plain text. You know, I'm pretty old school. And then I go and get the interesting payload. I do some things. I do a billion of things. The billion of things, there's no shortcut to that. The CPU is spinning a billion times, incrementing, and checking and checking and checking. Meanwhile, another request comes in, but the event loop can't trigger this function yet. The function sits there ready to be called, but because we only have one executing thread, this thing is chewing it out and not letting other people make requests. Bastard. So inconsiderate. So, yep.
I missed the last console response. What's happened to everyone?
What's happened to everyone? What's happened to everyone?
So everyone got a 5-second response.
No, so okay, yeah, I should have explained this a little clearer. It took, the previous one said the total time for test was 2.5 seconds, the time per request was 2.5 seconds, and the time per request across all concurrent requests was 2.5 seconds. This one, with a concurrency of 2, so that's both requests fired at the same time, the total time for the test is 5.5 seconds, más o menos, which I'm no mathematician, but I think means that it operated basically as badly as if the request had happened serially, which is the worst possible case for a web server. If it's a program, or maybe we're just doing a front end, because this is the joy of being a front end developer. I'm writing code for one person, one concurrent user. And for anyone who's unsure, one concurrent is not concurrent. Right, this talk has taken a really long time. You should all know about AB. You should all know not to block the event loop. I am going to stop this talk here because I could talk for hours about this, and this is a 2-part talk. You'll have to come back next month. That's the experiment that we just did. We blocked the event loop. We saw a thing. As an aside, everybody has greater than or equal to 1 talk in them. I have about a quarter of a talk in me, stretched out over about 20 minutes. I promise that this talk will be even more informative next month when I actually tell you how fibers work, which was the plan. But I fear I've taken up too much of your time, so thank you everybody. This has been Meteor London. Give a talk, tell a friend. That is the end of part 1. Wasn't it fun?